Welcome back to Calculus with Applications for our 7th week of remote learning. Before proceeding with this video, you should open the Definite Integrals and Velocity video capture sheet provided. You will be asked to complete tasks in the document throughout the video. In the previous lesson, we learned the antiderivatives of basic trig functions and exponential functions. In this lesson, we seek to put these antiderivatives to use in evaluating definite integrals, and we will also use particle motion as a real-world example where these functions might arise. Here are the antiderivatives you learned in the previous lesson. These 6 trig functions and these exponential functions. Let's now put these to work. Let's take a look at a definite integral that involves one of our new functions. If you would like to attempt to solve this first by yourself, pause the video. Using the fundamental theorem of calculus, our goal is to find an antiderivative and then evaluate this function at the two limits of integration and subtract. Recall that the antiderivative of sine is negative cosine. So for the antiderivative, we have negative 10 cosine x. Now substituting pi over 3 and 0 into this antiderivative and subtracting, we have the following. Some of the problems you'll encounter this week will require that you remember how to evaluate trig functions at special angles, such as pi over 3. Making these evaluations, we have 1/2 and 1. It's important to notice here that we can't immediately assume that because the lower limit of integration is 0, that the antiderivative will be 0. In this case, the cosine of 0 is 1. Finishing our work, we have a final answer of 5. As one final point to make on this problem, I want to give a warning about being careful with your negative signs. My suggestion is to make careful use of parentheses to keep your work organized. Now try 2 more definite integrals on your own. You may want to consult your notes for the antiderivatives needed. Let's take a look at the answers. The antiderivatives of e to the x and negative 1 are e to the x and negative x, respectively. Evaluating the antiderivative at 8 and 2 and subtracting gives e to the 8 minus e squared minus 6 as our final answer. For the second integral, we find the antiderivative of each expression and substitute 4 and 1 and subtract. Remember that the natural log of 1 is 0. Simplifying, we obtain the natural log of 4 minus 78 over the natural log of 3. Now let's take a look at a problem involving particle motion. Suppose a particle moves left and right with velocity given by v of t equals 12 e to the t minus cosine 5t, where v of t is measured in meters per second. And we are asked to find the displacement of the particle on the interval pi over 10 to pi over 5. Pause the video to think about how you will approach this problem. If you understood this problem is solved by finding the definite integral, you are correct. Pause the video and take the time to work out the integral if you have not done so already. The antiderivative of e to the t is trivial, but the integral of cosine 5t requires that you remember the chain rule. Can you see why the 1/5 is necessary? Substitute the limits of integration and subtract. From here, the work looks messy, but it's somewhat straightforward. Evaluating the sine of pi and pi over 2, we have 0 and 1, respectively. And our final answer we will report with units of meters. Let's take a look at one last problem involving particle motion. Suppose a particle moves left and right with velocity given by v of t equals 2t plus e to the t over 4 minus 3, where v of t is measured in meters per second. We are asked to find a position function, x of t, and we are also told that the particle has position 20 meters at time 0. Pause the video to think about how you will approach this problem. In this case, we seek a function x of t that has v of t as its derivative. That is, x of t is the antiderivative of v of t, so we set up the following indefinite integral. Pause the video and find the antiderivative. Did you deal with the chain rule on e to the t over 4 correctly? Did you remember the plus c? Feel free to pause the video again if you want to see if you can finish the problem from here. Did you figure out how to use the fact that x of 0 is 20? We make substitutions on both sides. Then simplifying and solving for c gives c equals 16. And we can write out x of t with the appropriate c value as our final answer. In this lesson, we applied our knowledge of antiderivatives to evaluate definite integrals and deal with particle motion. You should now be comfortable with problems of these types involving a wide variety of elementary functions, including exponential and trig functions.